This is the second video of my solution to our first formative on writing algebraic expressions. And so I solved the first three problems in part one. You should check that video out if you haven't. And then in this video, I'm gonna really dive into question number 4 right here. So let me begin by just reading this. We're going to write two algebraic expressions, the square of the sum of a and b and the sum of the squares of a and b. And then we want to know whether these expressions are equivalent, and we need to justify our answer, it says. And we'll get to that. So the first thing I'm going to do is write an expression that represents the square of the sum of a and b. So I'm squaring the sum, which means I have to first perform the sum, a plus b, and then square it. And the other expression that I'm asked to write is the sum of the squares of a and b, which means I first have to square the a and then square the b and then add them together. So those are my two expressions. And then our question, or what we need to figure out, is whether or not these are equivalent. And there's a couple of ways to go about doing this. The first method, let me just think about, I should be able to rewrite an algebraic expression in order to make it look like an equivalent expression. So if I can rewrite the expression here on the left and have it just use, the appropriate properties of addition and multiplication and so on to rearrange this expression to look like this one, then I can say that they're equivalent. Let's see what happens. Remember, when you square something, you're just multiplying it by itself. That's what this is. And here I need to use the distributive property to do this multiplication. This a is going to multiply the a and the b in the second parentheses. And this b is going to multiply the a and the b in the second parentheses. And I end up with a squared plus ba plus ba plus b squared. And these two terms in the middle I can combine together, and I get a squared plus 2ba plus b squared. Now notice right away that these two expressions are the same except for that extra term that I have. So this expression can't be equivalent to this because I have this extra term. Now it's true that, imagine if you put 0 for a and b, then this would be 0 squared and that would be 0. And this would be 0 plus 0 and it would also equal 0. So there might be some values for a and b that make these two expressions equal, but they're certainly not equal for all values. And you can see that by just imagining this extra term in the middle. So you could make a statement in order to justify your answer. Sure, you've kind of done some work here, but when you justify your answer, you really need to make a statement. So a plus b squared contains an extra term when you expand it. So it is not equivalent to a squared plus b squared. And I hope you noted this is a very common mistake among many algebra students. They see this expression and they just want to square the a and square the b and make it look like this. Clearly you can't do that, right? You have to use some different, squaring the sum is a little more complicated than just summing the squares. So I also wanted to do a different solution, really not a different solution, but a different justification. I do have my same two expressions, and so let's just imagine if a equals 1 and b equals 2, let me fix that. If a equals 1 and b equals 2, okay? What we get here is 1 plus 2 squared from my first expression. And then I get 1 squared plus 2 squared for my second expression. This becomes 3 squared, which equals 9. And this becomes 1 plus 4, which equals 5. So these are not equal. So if A equals 1 and B equals 2, then we've demonstrated with a single counterexample that these two expressions are not equivalent. So we can say A plus B squared is not equivalent to A squared plus B squared when A equals 1 and B equals 2. And that's enough to justify this. We can just give that single counterexample. But notice I did make a statement after demonstrating this work. I did make a statement that summarizes my justification.